Okay, guys, today we are going to be getting into section 1.2. In 1.1, we were talking about ways to visually put numbers into a graph and different kinds of data and how a certain graph would be beneficial in a certain time. Now we're going to talk about all of the numerical things we can say about a distribution, about a set of numbers. So this is just a small sample of the ages and months that we took in class the other day. So these are 10 numbers just to keep it small and to learn these things. You might be finding these with much larger sets, but we're just going to keep it basic with 10. So let's start with some old basics, mean and median. Okay, so I don't think I need to tell you what these are. The mean is what we usually call the average. We add them up and we divide. The median is the middle number. If you have an even amount, then the middle number, there isn't necessarily a middle number, so our middle, in this case, our median would be 191.5. We would take the average of the middle two numbers. So other than that, what you need to know about mean and median is that the mean is sensitive. Okay, a median is more resistant. But if you throw some outliers or some big extreme or small extreme numbers in a list of data, the mean is going to react severely. Okay, I've added myself into this list at whopping 406 months old, and let's see what that does to the mean. I've entered these numbers into my calculator, so I'm going to show you at the same time that we're talking about this how to find these things in your calculator. Most always we're going to go to Stat and hit Enter while we're on Edit and enter things into List 1. Now once they're entered in there, you can go back to Stat, go over to the Calc menu, and just hit Enter on one variable, Stats. And it's defaulted to List 1, so you can just hit Enter again. Now these are the bits of info about these 10 numbers. The top one, X bar, that's mean, X with a little line over it. So our average is 213.9. So obviously that's not a good descriptor of this list because no one except me is that age or higher. So you can see what my 406 did by pulling that average up. The median, though, if you scroll to the bottom of this list, N is how many numbers there are. Then we've got min, Q1, median, Q3, and max. We'll talk about those Qs in just a minute, but the median, there it is, 191.5. That's a much better choice to describe the class or this set of 10 numbers because it's not sensitive. I could have been 1,000 months old and it wouldn't have changed that median a bit. That's what we mean by sensitive or resistant, or the median is resistant. The mean is the sensitive one. Okay, so that's all I want to say about mean and median right now. So let's talk about those quartiles. The quartiles are basically specific percentiles that stand for quarters of the way through the list. Okay, we've got altogether, this is what's going to form the 5-number summary. The 5-number summary is made up of the minimum, the first quartile, the second quartile or the median, the third quartile, and the max. All right, so these 5 numbers just give us an idea of how spread out our list of data is. The median we've already established for this set of data is 191.5. The min and max are not difficult to find. Once they're sorted, we just find the min and the max. And then the quartiles. The quartiles are the medians of the upper half and the medians of the lower half. My lower half of data is these 5 numbers, and here's my upper half. So my quartiles are 181 and 211. And that's all there is to the 5-number summary. All right, we've got 5 numbers that explain how this data is spread out. All right, so that naturally leads us into our newest type of graph, which is a box plot. A box plot, sometimes called a box and whiskers, is a graph of the 5-number summary. So let's take a little number line and we'll label it And you don't have to label it in a lot of detail. Just make sure you get your 5-number summary on there. I need to get from 178 to 181 to all the way up to 406. So I'm going to have quite a bit of distance between my highest number, or my quartile, and my max number. And we'll see what to do with that in just a minute. But let's start our labeling at, we'll just go by tens, and I'll go 170, 180, etc. If I kept my measurements the same, which I should in a graph, 406 would be off the charts here. So I'm going to put a little squiggly symbol, which means that I'm not to scale on the right-hand side of this graph, just for the sake of spacing. Okay, so box and whisker, or box plot. At the quartiles, at 181, which is about right here, and at 211, which is about here, we're going to draw a box. At the median, 191.5, about here, we've got the median, a line through the box. And then the whiskers, so to speak, go out to the minimum and the maximum, like that. Okay, so there's a simple box plot. What's called a modified box plot will be a little bit of a variation on this procedure. So let me get another copy of that stuff, and try that again. Okay, so on this copy of the graph, I'm going to modify it. Here's what it means to modify a box plot. Instead of going all the way out to the number, which is going to end up being an outlier, and I'll show you how to determine it's an outlier in just a second, I'm going to stop at my next biggest number. And keep in mind, with 10 numbers, it's hard to get, accurate stuff here, but we'll just do the best we can. The next biggest number I have is 213. So instead of going all the way to 406, I'm going to stop at 213. About right here. Then I'm going to put a star out at 406 to represent the outlier. The reason we do this is because that gives us a way to tell, are there numbers equally spread out all down this time period, or is 406 just a crazy observation? And it turns out that 406 is just a crazy observation. So there's a modified box plot. All right, when we modify, we just take the outliers out and put stars in. All right, so let's go back to our calculators. Stat plot. Get rid of that. Okay, so second y equals, when we go into our graphs. If I want to draw a box plot, I just go down and select box plot, like this. I'll use list 1, and zoom 9 always gets me to my plot. And you can see this thing's very distorted because of my outlier. All right, you can barely even see the bottom half of the box. If I change that, plot 1, to a modified, all right, your calculator is built-in modified, you can see what it does. It changed that to just one observation way out there. My box plot's still pretty messed up because of the graphics on my calculator, but at least now I can tell that that is an extreme observation. I don't have numbers spread out all the way across there out to 406 like it looked like I would. All right, so there's how you draw those graphs. And now let's talk about outliers. How is it that I know mathematically 406 is an outlier? Besides, hey, it's just a number that's different than most of the other numbers. Because at some point, it's just the biggest number, but when does it cross over to outlier status? That's our next topic. Okay, here's a simple formula for outliers. The IQR is the third quartile minus the first. So for us, in this scenario, that is 211 minus 181. All right, and I believe that 211 minus 181 is 19 and 11, 29. Looks like about 30. 1.5 times the IQR is the number we need. So for us, that's 1.5 times 30, which is 45. Take that 45, add it to Q3 and subtract it from Q1. So we're going to go Q3 plus 1.5 times the IQR. And we're going to take Q1 and minus 1.5 times the IQR and see what we get. So let's see, that's 45. We need to take 45 from 81, from 181. 181 minus 45. That is 136. And, oh, excuse me, that's here. And we need to add that 45 to Q3. Q3 was 211, and 211 plus 45 is 256. What we've created here are two cutoffs for determining is a number an outlier. Okay, let's say I had been 250 months old. Am I just a big number in the list, or am I an outlier? Well, mathematically speaking, anything over 256 or under 136 is an outlier. Okay, so that's kind of like your fences, your cutoff points. Anything outside this is mathematically an outlier and will be turned into a star on the modified box plot. There are a couple ways to calculate. This seems to be the most common one. I am honestly not sure if that's the way a TIA calculator does it. I'll give somebody a bonus point if you can tell me if that's how your calculator decides to make it into a star. I think it is, but I'm not positive. So what we've got so far, mean, median. We don't even really mention mode anymore, but that's the most common one. 5-number summary, box plot, modified box plot that you make when you have outliers. From here on out, if I say make a box plot, what I'm saying is make a modified box plot, so you have to check for those outliers. Okay, so quickly, let's see what other kind of info the calc will give us. We'll do some of this by hand eventually, but I want to end this particular video. If you go back to your stat menu, over to calc, one variable stats, and enter. Here's the list of stuff that it tells us. It tells us the mean, 213.9. It tells us sigma x. Sigma always means sum, so if you just wanted to add up your numbers for some reason. It tells you what if you squared them and then add them up, which would have, application in some stats. We won't really use that number. The next one I want you to think about is S sub x, this next one, 68.6. That is an important number. That's our standard deviation. Just for now, and we'll probably do one by hand eventually, but for now, standard deviation on your calculator is right there. And then you've got your 5-number summary at the bottom. All right, so again, this section is about taking a list of numbers and coming up with all of the characteristics of that list numerically. Some of them you've probably seen before, some you have not, but we're just working on analyzing and describing a set of numbers. All right, so that'll do it for the first part of 1-1. This is Young, and I'm training to become a cage fighter.